Hello everyone, welcome to this new video tutorial where we are going to go through element appearing more than 25% in sorted array. So you are given an integer array sorted in non-decreasing order, and there's exactly one integer in an array that occurs more than 25% of the time. Return that integer. So you have an array like this, and then you're just supposed to find out the element that appear more than 25%, and then in this case it's actually 6. Why? Because we have an array of how many elements? 4 and 5 to 9 elements here, and then we have 6 which appear 4 times, which is kind of a little bit above 30%. So it is actually respecting this condition. Given this, how are we going to solve it? How are we going to organize ourselves to solve it? So there's one interesting thing you need to pay attention to, is the fact that there is exactly one integer. Given that there's exactly one integer, you can just omit the 25% and just focus on getting the element that occur, like the biggest number of occurrence, and that element is definitely going to be the element that occur more than 25%, since there's only one. So now if you want to approach the problem that way, how can we solve it easily? So let's say you have an array like this. We know that the array is solved, right? So we can leverage the fact that the array is solved to kind of find out the number that occur the most number of time. So for us to do that, we are going to take it this way. We are going to start with this element. So we are going to have an index here, which we are going to call maybe previous, and then we are going to start here. And then by starting here, we are going to say, okay, is this element actually equal to the previous? No, it's not equal. If it's not equal, then we count the number of elements that was here previously. This one is actually 1. So it is actually our result. Then we move. So we are going to erase this pointer here. Since we are now here, we are going to point it here. Now here we are going to have our p here, and then we are going to have let me grab another color, and then we are going to have our second pointer here. We are going to have our previous here, and then we are going to have our index here. We are going to check, is this one equal to the previous? Yes. We are going to come back here. Is this one equal to the previous? No. If it's not equal, we compute the difference in between this actually element and the previous, which should actually be this element. And then since this is actually greater than the previous result, this is going to be the result. And this is what you're going to do until you reach the end of the array. So basically there are actually 2 elements that kind of trigger us to perform computation. Is actually having an element which is different with the previous, or being at the end. That means being at the index which is actually equal to the length. So that's what we are going to use here. We are going to have our for loop, and then we are going to have our condition, which is actually if we are at the end or if we have an element which is different, because those are just the 2 conditions that we need to pay attention to. And then once we are there, the next thing we need to have is to find the length of the element that has been that we have in between, like the previous and where we are now. And then we just compute it by just making the index minus the previous, like we did here. If you are here, the number of elements is just this index minus this one. It will give you the number of elements. Now that you have the current, you just need to compare, is the current actually greater than the previous result? If the current is greater than the previous result, then this is actually a potential solution. If it is a potential solution, what you need to do is that you need to keep the number of occurrence, because that is the element you are performing the condition with. That's why you do this. And then you need now to keep the element, because this is actually what you're going to return. Okay, and then at the end of this, after each operation, you just need to say, okay, the previous element is actually equal to I. Why? Because you want to move your previous pointer to the current, to the new element, and then now you start navigate again. So by doing so, you'll be able to have something which is actually working. Okay, so this is how it's performing. Really strange that you just performed 8 milliseconds whereas it was just 4 milliseconds, the same code. Okay, so see you in the next video. Ciao.